rid of the mucus, the cells slough off, you get an inflammatory response. All of these things are going on from the infection. Humans are the only source of the common cold. It requires close contact. You got to have, direct transmission, droplet nuclei. So you would think if we're the only source of the common cold, why can't we wipe it out? We should be able to get rid of it. Except for there are just way too many strains. And like I said, they're they're highly variable. They're changing regularly, so our immunity is going to be short-lived. There are too many to make vaccines. You pretty much have to treat the symptoms. We don't treat for common colds. We don't give you antibiotics for common colds. We don't do anything to get rid of the virus. You have it. So you have to suffer through it very much. Adenoviral pharyngitis. This is a widespread viral infection manifested by a sore throat, enlarged lymph nodes, can cause fever. There's some 45 different types of viruses that would fit this description. They're non-enveloped. Okay, so when you think about it, what that means then is that we're talking about a microbe that doesn't have this envelope around it. It's a naked virus, if you will. This microbe is prevalent in school children, crowded conditions. We don't have treatment for it. Again, you just have to suffer through it. We can treat the symptoms, the runny noses that come along with it, and the fever and stuff like that, but we can't get rid of the virus. Okay, let's move on down to the lower respiratory system and consider some bacterial infections of the lower respiratory system. Well, the condition is known as pneumococcal pneumonia. And this is a condition that can be caused by any number of microbes. One of those microbes, the most common, is Streptococcus pneumonia. Again, this microbe has a thick capsule, and this thick capsule provides it some protection, kind of masks it from our immune system, allows for its virulence. There's some 80 different types of this microbe here. As you can imagine, you have to inhale it. It makes its way to the alveoli where it will multiply, cause an inflammatory response. You initially get resistance because of the capsule. So you get some resistance because of the presence of the capsule there initially, but within about a week or so, that resistance is subsided and we are now destroying the microbe. Our macrophages are engulfing it. The capsule actually interferes with the C3b, so we don't have that complement binding, opsonicizing the microbe. What you have happening here is that the lungs now are going to fill with serum, and so they fill with fluids. Other conditions that you can have pleurisy where the membrane lining the lungs becomes infected, meningitis, endocarditis, or other infections that can happen from this initial infection. About 30% of us are actually carrying the microbe as part of our normal microbiota, as part of our normal flora. We're carrying it around. We do have a vaccine that's good for about 23 different types, so you can see we're not going to be able to treat all of them with the vaccine. But we can cure it with penicillin and erythromycin. Klebsiella pneumonia, also a microbe that causes pneumococcal pneumonia, causes pneumonia deep in the lungs here, is one of those microbes that is common, is a common nosocomial disease. So this microbe colonizes the throat, gets inhaled into the lungs. It avoids phagocytosis again by interfering with complement C3. But unlike Streptococcus, this microbe here actually does damage to the cells. Streptococcus doesn't damage the cells of the lungs, but Klebsiella does. It also releases an endotoxin, an exotoxin. That exotoxin can make its way into the bloodstream where it can find other tissues and do more damage. So this is a much more serious condition than Streptococcus pneumonia. One other type of pneumonia we can talk about. Mycoplasma pneumonia. This is also known as walking pneumonia. It's common among college students. It's one of those that just kind of hangs on. You have a fever, you have a headache, muscle pain, dry cough. One of the reasons for the fact that it's so long, if you will, in recovering from is that it lacks cell wall. It doesn't have any peptidoglycan. So it's hard for our immune system to recognize the cell. It'll attach to respiratory epithelial, and it inhibits ciliary action, so you get the cough that comes with that. We don't have a vaccine for it, but it can be treated with antibiotics. Questions?
If you have the Streptococcus pneumonia as a normal microbe, and you're sick, you still get someone else sick?
If you have it as part of your normal microbiota, can you get somebody sick by passing it to them? Absolutely. If it's something that they don't have an immunity to, it could make them sick. If their immune system is depressed, even you could get sick from it. It could be fine. You could be fine with it normally, and then if your immune system becomes depressed, then you could be sick from it as well. So yeah.
Is there a thing called, is there a viral pneumonia?
Sure, I'm sure that there are pneumonias that are caused by viruses. I don't have any that I'm going to go over. But I could look back and see. There's a I'm sure there is. I'm sure there's something out there that causes similar conditions. You know, and that's what we're talking about here, similar conditions. Moving on. Whooping cough. Been in the news for the last couple of summers. A condition caused by the microbe Bordetella pertussis. It's not as common in the United States as it was at one time because of immunization, but as we see, it is coming back. Every once in a while when our immunization lacks, we can see it come back into the population. It is still widespread worldwide, so it's in many countries worldwide, especially the poorer countries where you don't have vaccination. So what you have here is that the microbe attaches to the ciliated cells. It grows in this very dense mass on the surface. This mass here then can interfere with the ciliary action. You get some increased mucus production, and then, of course, to get rid of that, you have very forceful coughing that takes place to get rid of that mass of cells and mucus and stuff that's accumulated. So you have these very forceful coughs, and then that is followed by inspiration that you often comes with a whoop, because the air is rushing back into the lungs after those forceful coughs. It creates that whoop as it passes through this mass of cells and stuff that's clogging up the lungs that you've got going on there. Several toxic products are produced. They're AB toxins. It's spread by respiratory secretions. We do have vaccines given to infants. Can be treated with erythromycin. Any questions about whooping cough?
Is it the same microbe that causes kennel cough?
Causes what?
Kennel
Kennel
cough?
cough?
Like dogs?
For dogs? I don't know, is it? You're the vet?
Bordetella does, I don't know if it's the same.
Bordetella pertussis? It very well could be. I don't know. That would make it a what? Zoonosis. But I doubt that you could catch it from your dog. Yeah, it's probably not cross species. I don't know. I don't know if it's the same one. Tuberculosis, caused by the Mycobacterium tuberculosis. So this is a disease that's probably been around about 3,000 years. It's a slow-growing microbe, and it's unique in that it has an acid, a mycolic acid, in its outer cell wall there. And so that allows it to avoid our host defenses. The microbe is taken up, you inhale it, makes its way into the lungs, where macrophages will be drawn to the area, and the macrophages will then surround the microbes and form what are called granulomas. Basically, what the macrophages are doing is they're walling off the microbe, preventing its spread. Now, for the most part, we identify this as happening in the lungs, but you can have these granulomas form in other places as well. The initial infection is generally localized, but the bacilli can survive in these granulomas for months or for years. And then they can break free occasionally, and then they can spread to other areas, other tissues. As I've mentioned before, we do have a vaccine for this microbe, but we don't give it in the United States. Our concern here is that if we're vaccinating people for tuberculosis, then we won't be able to follow the spread of the disease because they'll test positive for tuberculosis. And so we won't know if they've been exposed or not, or if it's because of the exposure or if it's because of the vaccination. However, there is a new product out called T-Spot that I have a video I can show you that actually addresses that issue. And so maybe now we will be able to vaccinate because we'll be able to distinguish between those that are testing positive because of vaccination versus those that are also infected. That's it for the bacterial infections of the lower respiratory system. What's that? You wanted one more? Let's quickly look at the viral infections of the lower respiratory system. So we've talked about influenza already a couple times in class. So this microbe constantly changing. There's an interaction between us and the agent. I talked about this red queen scenario where we're